If everything is okay, we can start. Today I'm going to present to you a part of my book and the ideas from it called Design Patterns for High Quality Automated Tests. Okay, we can start. Yeah, just a second. So, first, who am I? I'm Anton Angelov, co-founder and CTO of Automate the Planet, and my role is to, I created the framework called BELLATRIX and the MEISSA distributed runner. For 10 years now, I'm designing and writing scalable test automation solutions. For more than 6 years, I think, I worked in 2 big companies here in Bulgaria called Telerik and Progress as QA architect. And maybe many people know me mostly for my blogging for Automate the Planet and many given talks. So let's begin. What we are going to talk about. First, we are going to talk about a few definitions, of course. Sorry, there will be some theory, because as you know, I want all of us to have some shared dictionary and words. Then I will explain what I mean under high quality test attributes. This is something I defined in the book, and I think it's vital for creating high quality tests. Then, of course, in order to achieve these high quality test attributes, I'm going to present to you many design patterns about each one of them. And of course, through the presentation, there will be a lot of demos. That actually all of the code from the book is open sourced, and I will explain it to you. And of course, at the end of the presentation, there will be some questions that some of you already asked through our registration form, and I will try to answer them. So let's begin with the definitions. I'm really excited. First, what is a software library? Well, the software library is something it's a pre-written code, like classes, methods, scripts, configuration data, and more. You can use it later on in your code, tests, etc., without writing it every time again and again. The most famous example in .NET is the .NET time library, working with date and times. And what is a software framework? Through many interviews that I performed, many people told me that for a QA role, all of them wrote a framework, but actually they didn't know actually what is the difference. Well, the difference is that the framework is something more abstract. It provides a generic functionality, but there are 4 major things that differentiate the framework from the library. The first one is the so-called inversion of control. It's something that actually the framework controls the flow, not the user. Then the framework provides a default behavior. This is not the case every time for the software libraries. And the biggest difference here is that you can extend the framework. It's something more abstract, it's something more generic. Usually you can do it by overriding some of the methods. You can use hooks, event, delegates, plugins, etc. There are many different cases. We will look at some later on. And you can extend the framework, but you cannot modify the code. And what about the test automation framework? Well, the test automation framework is an extension to the software framework, but imagine this situation. In typical web test automation framework, you can have one project for coding your page objects. We will look in them later on. Depending on the framework, there are many types of page objects. You can follow different rules. For example, all of the elements, assertion sections may be in one file, but in other cases they may be in different files. You can expose the elements, in certain cases not, and so on and so on. But you need to choose your way. We'll see some examples later on. Then if you choose to use BDD, like specful or Gherkin language syntax, you need a project where you need to, define your steps, implementations, and all of the tests, etc. Then you may decide that you need a static analysis tool, and in order to use it, you need a special file where you need to define all these standards. Usually they happen in special files. And as you can see, the test automation framework is not only about the methods and classes, but actually is how we use them, how we group them, what rules we follow. It's something more complex. So, and lastly, what is a design pattern? You can read the definition here, but basically this is a code. It's not only about the code and not only about the algorithm. Instead, the design pattern, it's something how you group your logic smartly, how you reuse it, how you maintain it. It's like a template for solving particular problem, as you will see later on. And the important part is that for any design pattern is that you can implement it in a few different ways. Another thing that it's important in the book is that in order to write high quality tests, it's not only important to follow high quality test attributes that I will talk about later on, but you need, we QAs, and especially I don't actually like the word test automation engineer, but actually software developer and tests. We are software developers, and we need to follow all of the major and important programming best practices. Maybe the most important principles in object-oriented programming is the so-called SOLID. It's an acronym for all of these different principles. I'm not in the book. There is almost a whole chapter about them. I'm not going to talk about them right now because the whole idea of the webinar and the presentation is about design patterns for, and there are many things that I want to show you. But you can find a lot of information online, and I suggest you to do so. But anyway, there something that I refer many times in the book when I talk about high quality tests. And what are the high quality test attributes? Later on I will show you many different design patterns, but I will just list them right now. The first one is the test readability. This is how easy it is to understand what is happening in the test, what the test is doing. Are there many nitty-gritty details that you don't need? Is it easy for another colleague to understand what the test is doing, or even for non-programmer? This is test readability. The next step, the next attribute is the test maintainability and reusability. How easy is, when you already wrote the test, how easy is to, when it fails, how easy is to find out whether there is a real bug or a problem in the test, how easy is to fix it, how easy is to create a similar test, do you reuse the logic or just copy paste it? This is this attribute. The next one is the API usability. This is one that I really like. It's actually how easy is for new people to understand how to write a new test, how easy it is for them to use your framework. They need to read a lot of documentation before they get started. It's somehow related to the previous 2 points, but it's a little bit different. And if you recall, the description about what a software framework is, maybe the major part is the extensibility. So this is why here, this is a major vital attribute, the extensibility. How easy is to write new plugin? For example, if you want to create screenshots on failures or videos on failures, how easy is to write a logging to all of the actions? How easy is to, add a new step? in the workflow without causing a lot of regression in your tests. And the last high quality test attribute is the so-called learning curve. It's somehow related, all of them overlap between each other. The learning curve is how much time a new team member needs to learn how to use your framework, how to write a new test, how much time is needed for onboarding. Do you need to spend 20, 30, 40 hours to lead a lot of lectures, training, etc. In order new colleagues to start working on? As you can see, it's related to the API usability, it's related to the test readability, it's related to test maintainability and reusability because it's connected to, you know, usually junior people, we leave them to maintain and fix and look at the test results. So the learning curve is really important. So I will now, before proceeding with all of the demos and design patterns, I want to talk about really quick about some of the reasons for why tests fail. Sometimes there might be a real bug in your system, a real problem. This is the best case. Your bug, your automated test is doing its job. Many times there might be a test environment problem, the website redeployed or it's not available at the moment, there was a networking issue and so on. There is a problem in the test itself, the so-called flaky tests. They are passing sometimes they are not, because in a minute we will see some flaky tests. You use it, there are many reasons why the test may be flaky. There might be a problem on test dependency. Imagine that you have 3 tests. The first test, the second test depends on the first that it already logged the user in the website or in the system, but for some reason the login failed, and this means that the second and the third test failed because the first test couldn't log in the user. So this is a simple example for test dependency, and of course it's not the best practice. Usually the best practice is to write the tests that they don't depend on each other, and this will ease you to run them in parallel and so on. Another problem might be hard-coded test data. In New World right now, usually in the corporate world, we have more than one test environment. This means that if you use hard-coded data, sometimes this may mean that you don't have the data on this particular environment, or you need to create it again, or you need to restore the database. And for some reason, if the data is not there, your user is not activated, or it's not there, or the product that you want to buy is not there, this will cause your test to fail. And about the code duplication, if you just copy paste the tests and the workflows, etc., it's really easy to imagine that sometimes you fix 2 tests but forget to fix the third, or if it's the workflow is not in a common place, you just forgot, and it's easy to imagine why the test failed. Now let's go to some demos. For the book, first you can find the book on Amazon, Design Patterns for High Quality Automated Tests. Then on GitHub, there is a free GitHub repository containing the demos for all the chapters. Actually, we will go. I already downloaded the GitHub repository, initialize it, and I will explain the different examples from this GitHub repository. And through the book, I wrote all of the examples on this demo application. It's a real shopping cart that simulates buying rockets. I will explain. I usually created 3 simple tests, and through the presentation we will try to upgrade them. So the first version of the test will be really lame using hard-coded pauses, but let me show you what we do in the test. First, we navigate to the Demos BELLATRIX shopping cart. We add to the cart this Falcon 9. Go to the view cart. We wait for the page to load. It's not so fast. And then we have a birthday, so we apply discount. It's already there. Okay, I will remove it. So we have a coupon discount, $5. So we decide that we have enough budget to buy a second rocket. So we update the cart. We wait, as you saw, on all steps. Instead of reloading the whole page, the shopping cart is written in a way that it uses AJAX asynchronous requests. So we will need to find a way to battle that. And then we proceed to checkout. And on the checkout, the first test, fill all of these different fields here, creates an account, and then place the order. And our second test actually is for a returning customer, in order to not to fill all of the data here. And there we click on the login, pre-fill the email and the password, we log in, and then place the order. That's it. And now let's check the demos from chapter 1. I hope that all of you know how to write tests for WebDriver, so I will not go in detail how to how to create such tests. I will just try to explain them a bit. First, you have the driver here as static. Actually, not this version, but this one. First, we have the iWebDriver. Before all of the tests, we initialize the Chrome browser and we start it. After all tests, we close the browser. And we have 3 tests here. In the first tests, we first navigate to the shopping cart. Then, as you can see here, first we find the add to cart Falcon 9 through find element and using CSS selector. We click on it, and because all of these asynchronous requests that are happening, we need to wait a bit. And we are junior programmers, so we use hard-coded pauses, in this case half a second, in order to battle that. Then we click the view cart, we apply the coupon, and again, when we apply the coupon, we click the apply coupon button. We need to wait a few seconds. Here we wait 2 seconds in order to wait for the coupon to be applied and to assert this notification over there, and so on and so on. Through the test, the important part here is that in the test we every time directly in the test find the elements and use hard-coded pauses. Only for this single test here, as you can see how long it is, we have something like, we wait for 15 additional seconds, something like that. We have a second test that we basically almost completely copy-pasted, but here we log in instead of typing all of the data. But again, the important part is that we use thread sleep or hard-coded pauses, and the tests depend on each other. And now let's see how we can fix that. The first way to fix that is to use the so-called implicit wait. The implicit wait is a way of WebDriver, many of you I'm sure already use it, is to tell WebDriver to wait for a particular interval of time until all of the elements, the particular element is found. For example, we here wait for 30 seconds. We may decrease it to 10 seconds, but in certain cases we may need 30. So basically, since this is a general timeout, you need to increase it as much as possible. So many people don't like to use it, and because of that they use the so-called explicit wait, or the so-called WebDriver wait until. This will wait for, actually this until syntax can wait for many different things, not only for waiting for element to exist, but the element to be clickable and many other different conditions. But the good thing here is that we can, as I will show you in the example, fine-tune it. This means that for particular cases when we need this interval to be short and we are sure that it will pass below 10 seconds, we can optimize it and the WebDriver to wait only 10 seconds. And the other places we can wait for longer. Let's see how we can do that. In the examples here in version 2, actually below my tests here, they're almost the same, as you can see. I created three additional methods. One of them is called wait and find element. And here we create this WebDriver wait class. And we first wait for the element to show up, and then we return it. And we have the same method for many elements. And since we use default parameters, by default we wait, default is 60, but actually everywhere we can decrease it. For example, here I can mention that it's 10 seconds and so on. So instead of calling driver.findElement, we call our helper method here. And we will be sure that WebDriver wait will wait until our element is found, and then we will return it and we will perform the action, which is much better than the hard-coded pauses or the general timeout. Just a second, I need to mute. Which is much better than okay. So another way how you can improve the design with wait and find is to use the Decorator design pattern. I'm not going to. You can find an article on Automate the Planet blog about it. But I will show you an example, and I think you understand the most basic idea about it. You can imagine that the decorator is something like a wrapper across the element or the WebDriver and so on, and its basic idea is to improve the API also. So let's see an example. So in the decorator, we have an abstract class on interface where we define the whole API. In this API, we define that we have a start method, which initializes the driver based on this enum, initializes the correct browser. But actually, the most important methods that I want to mention are these two abstract methods, findElement and findElements. Basically, we will place here our wait and find methods from this version 2 here. Here is the implementation. This is the implementation of the decorator, the WebDriver implementation of the abstract class, where, as you can see here, we again use the WebDriver wait. Again, we have a decorator for the web element, but I'm not going in these details here. The important part is that basically we create an abstract method and we wait here for the element before returning it. And let me show you how much this improved the tests. instead of, you know, in every test class have all of these wait and find elements, actually we use, instead of iWebDriver, we use our decorator here, the WebDriver, and actually almost the syntax here is the same as version 1, as the native element now. But underneath, in this find element method, we actually first wait for the element and then we return it, which is, you know, improves the stability and optimize the tests. And as you can see here, we don't have all of these hard-coded pauses, which is much better. Another way how we can optimize the tests is that actually the WebDriver wait won't fix all of the pauses. We cannot remove all of the pauses right now. And this is why we need additional method for our WebDriver decorator, or basically you can use it, if you don't use decorators, you can use it just as normal helper method. You can create this wait for Ajax method where basically you execute JavaScript that uses the WebDriver wait, and it will wait until all asynchronous request finishes. Because in our case here in the card, when we you know, update or something, sometimes this may happen for half a second, sometimes it may happen for 1 second, 2 seconds, depending on the load. And this is why it's much more optimal to use such a method that will wait the exact time. And we will proceed when all the Ajax requests are finished. Another way, much more complex actually design pattern, as you can see there are many parts of it. I won't explain it, all of it right now. You can find an article on Automate the Planet, but I will show you just a bit of the code. Is to actually make sure to reuse the browser. Right now, and in many cases that I saw many WebDriver tests, many people start and restart the browser every time. But actually this is one of the most time-consuming operations. For certain browsers, the start operation for creating the browser takes up to a few seconds. And if you find a way how you can reuse the browser instance, and reusing the browser instance, this may mean that, for example, you clean the cookies and the cache and reuse the browser for each test, which is fine. We can use the observer design pattern. Let me check whether I have this demo here. I think it's Indianata solution for chapter 3. Basically in the book, the thing that I explained here is, here you can see the tests. Here we wrote through the observer pattern a way how you can basically start a browser, initialize the driver through an attribute. Here you can choose the browser, Edge, Firefox, Internet Explorer, whatever. And here, through the browser behavior enumeration, you can choose whether to restart it on fail, to restart it every time, and so on. So we can tell it to reuse if started. And if we check the browser infrastructure, as I said, it's too hard to explain it right now. I do like a half conference talk about it. So we can just check what it is. But basically, before each test, we check whether we should restart the browser or not. And we use a reflection API to get the value of the attribute. And based on it, we decide whether we need to, restart the driver or not. Again, this is a technique for optimizing the speed of the tests. I'm not going to explain in many details because you can find it for free and read it yourself, is the so-called black hole proxy pattern. The whole idea of the black hole proxy pattern is that here on Automate the Planet I created an article about it. It's basically almost, but not entirely identical to the book. The whole idea of the black hole proxy pattern is that you use a third-party proxy called Titanium Web Proxy. There are different proxies for the different programming languages. Basically, this is an open source proxy for .NET. The whole idea of the pattern is that you can block third-party dependency requests on your website. For example, Google Analytics, Facebook proxy, not proxies, but pixels, and similar stuff. You can block them, you can change them, you can redirect them, and so on. And this is why it's a black hole, because it absorbs the requests and block them. Another way how you can do it here, I used in this article something new that it's coming, the Selenium WebDriver 5.0, the Chrome DevTools API, and it allows you basically to do almost the same. Here we create a DevTools session and we need to initialize this set blocked URL command settings, and we can set different URLs that needs to be blocked. It's a little bit more it can change over time since it's still in alpha, but you will be able to do it in Chrome and in Edge Chromium. Again, you can read it yourself. It's free, available here on the website. This is why I'm not going to talk about it right now. And now it's time to talk about the different high-quality test attributes one by one. The first one is the test readability. By reading the code, as I mentioned, you should be able to find what the code does easily. And the code that it's not readable usually requires more time to read, to maintain, to understand, and it can increase the time to introduce bugs. And some programmers use huge commands instead of writing more simple readable code. And it's much more easier to name your variables, methods, classes correctly instead of relying on using these comments. And also, as the time goes by, the comments are rarely updated and they can mislead the readers. And there are different patterns that can make the test much more readable. As you saw in the first examples for our test, it's really long and it's really hard to understand and comprehend without all this explanation that I gave. So I'm sure many of you know the so-called page object model design pattern is the simplest way to improve the readability and maybe the maintainability of the code of the tests. For those of you that don't know what it is, I will explain it shortly. It's basically a class that holds the different web elements with all of their locators. The page object is a class that holds all of the actions that you can perform on a single page, and maybe in certain cases all of the assertions that you can perform on the same page. Let's look into an example. Let me vote the fourth solution, test readability. So here it's a simple page object that represents our card page. Let me recall what the card page is. This is the card page. So we have all of the links. We have an action for applying the coupon. We have an action for applying the discount. We have an action for asserting here the subtotal and the total. We have an action to proceed to checkout. We have a similar page object but another class for the home page where you can add the cart, and add the different elements and go to the cart. And we have another one for the checkout itself with all the fields and so on. So here is the cart page. We use composition. The composition is a principle where we use the driver here not from the parent class, but actually we use it as a variable and we paste it through the constructor here. In this particular implementation, there are like at least 10 versions of page objects through the book. In this particular first version, we actually don't expose the elements outside of the page. Actually, as you can see, they are private. And we expose publicly only the actions that you can perform. Applying the coupon, hiding the different actions that we perform to apply the coupon. The trade slips, etc., they are not needed. And the same for the main page. Here again we have these private elements and only the single action add rocket to shopping cart. And let's check the example how we use them. Again, we have this test class with the 2-3 tests. We initialize the driver, we call the start that initializes the Chrome browser, and we again we need to, as I told you, we use composition, so we need to initialize the pages and provide the driver to them so that they can find the elements. And you can see how much simpler the test is. You can see on which page what actions we do. It's much more, you see only the action, add rocket to shopping cart. You don't see how we find the elements, you don't see the pauses, etc. You only see the actions and the assertions. It's much more readable. However, in order to improve the maintainability maybe and somehow the readability, as you can see on the slide, there are many elements that can show again and again on the different pages. For example, this menu here, or the search, or the breadcrumb, or this icon here. And this is why we can use another implementation of page objects. I call it page object sections. Actually, the sections are something like a page object, but something like, let me show you an example. In this version here, actually in the third version, for the different parts that I showed you, the menu item, actually here you can see how much repeatable code there is. Here these links from the menu are available in the cart page, but also we have the same copy-pasted here in the main page, and we will have the same if we have another page for the third page part of the process. And we have the same for the search and the breadcrumb. In order to reuse that and not to copy paste it, we use sections. What are the sections? The sections are mini page objects, but we don't call them pages because it's not a page. We will have again in this case for actually the BELLATRIX website. Just let me open the website. Another section might be here the footer and the menu, the icon, and so on. So the section itself is again we paste the driver to the constructor. We use again we reuse the elements as private here, and for some of them we can expose public methods like open breadcrumb item, or for the info section we can get the current amount or open the cart. For the menu item we can have different methods for opening the different pages from the account. And how we use them? Well, we can expose them as public properties here, and we can initialize them in the page constructor. And how we can use them? I'm not sure that I have an example for that. Let me check. As you can see here, we initialize the main page, then we access the public property for the section, main menu section, and just open the bulk page. The same for the search info. This is how we can reuse them. If you need a section in another page, as here, you can reuse it again as public property. We use composition, which is much better than creating base pages. In version 2 here, I used another approach for using the elements. I basically created a base page for the menu item, for the menu items, for the cart info, for the breadcrumb. This is another approach. This means that my pages basically derive from this base page. But in certain cases, certain sections may not be available for the different pages. So the composition is much better approach using the sections. Let's proceed. Test maintainability and reusability. As I explained, this is related to how easy it is to customize and change your tests, how easy it is to find and fix problems, improve the performance. Imagine that there is a problem in the test. How much time do you need to figure out whether there is a problem in the system, problem in the test itself, or in the test environment? How easy it is to fix it? And the better the maintainability is, the faster we will figure this out. And the reusability is somehow related because, as you saw, if we can reuse some of the logic, it will be much easier for you to extend the solution, fix it, and so on. So let's see some examples. One such example is the so-called template meta design pattern. In the example that I will show you, actually, we use the template design pattern for optimizing the tests, for waiting for, as you will see, this is, I think, one of the best approaches to wait for page to be loaded. Let me open this particular solution. Test maintainability. So, in my base page here, and this is version 1 for the facade, so give me a second. Okay, so for some pages, like this one, we can navigate directly. And if we navigate here, when we are sure, especially when there are asynchronous requests, when you are sure that the whole page is loaded. One way to do it is to wait for for all Ajax requests to finish. Another way is to use the template design pattern. I will explain it really quick. Basically, in our navigatable base page, the navigatable means that this is a page that we can navigate directly to, because there are other pages, like, for example, the one that we fill all the data. It doesn't make, it's not a page that you can go directly, no. Here in this base page, navigatable base page, we create an abstract protected method called wait for page load. And we call this method here when we instruct the page to be opened. When we open the page, we call our logic for waiting for page to load. What we actually do here? Well, for each particular page, we override this abstract method, our template method. And we instruct it to wait for particular element to show off. For example, for the main page, we wait for the Falcon 9 button to appear. This is this particular button. When this is displayed, we decide that the page is loaded. For the card page, I'm not sure which button we use, but let me check. For the card page, we wait for the coupon code text field to show off, and then this one. And when this is displayed, then we decide that the page is fully loaded. And this is basically the template method design pattern, which means makes the test much more stable. The thing that we do here, this new method here, wait to exists, basically it's part of the element decorator, and if we see its implementation, again we use almost the same logic with the WebDriver wait and wait for this particular element to appear. I'm not going to explain it in much details right now, it's not so important. Another way how you can improve the test maintainability is, as in our case, we have this long workflow, but imagine that you need to add a new step to the workflow, a new assertion. And if you have, I don't know, 100 tests, this means that you need to go to 100 places to add additional method. Or if you change the parameters of all of the methods, then you need to, go to this 100 places and change it there. This is not so maintainable, right? So it's much better to have the whole workflow defined in a single place where you can replace it. And now I will show you, actually this is the facade. The facade is something like a place where you can define the workflow and reuse it. You understand it better through the example. Here I have created a class called purchase facade or purchase workflow, whatever. It accepts the different pages that the workflow uses. We initialize them through the constructor, and we have a single method for defining the workflow of all of these pages. We provide all the needed information through parameters. Again, it's your choice. This purchase info is basically all the information that we paste during the billing information. It's up to you whether this to be a single class or many parameters. I prefer to keep them up to 5. So here we create the whole workflow. We open the page, add the item to the shopping cart, apply the coupon, apply the assertions, and so on. If I need to change the workflow, I do it here. If I need to add another assertion, I do it here. If I, for example, change how we apply the coupons, I will add the change only here. It will fix immediately all the tests. Otherwise, if you have 100 tests like this, you will need to go to 100 places to change it. Let's see how the tests look like now. I think also this improves a bit the readability somehow. As you know, this is a test without a facade. So we first open the cart, we add the shopping cart, and so on and so on, and then we fill the billing info. This is a test without the facade, and this is the test with the facade. This is especially useful if you have a lot of tests with different data, but the workflow is not changed. You just changed here the this object, and this is perfect for test-driven tests where you can use different attributes for executing the same test again and again, but with different data. And yeah, this improves really a lot the maintainability and reusability of the code. What about the API usability? As mentioned, the API usability is how easy it is to use your framework or a library, and how easy it is for a new user without checking documentation to figure out how to use it, how much time is needed for that. In the programming community, we sometimes use another term for this called syntax sugar. It describes how easy it is to use or read some expression. It's within the programming language for humans, so to say. I will show you in the book. I describe 4-5 approaches for this. Right now I will show you 2 of them, the so-called Singleton design pattern and Fluent API. What is the Singleton? Just give me a second. Let me open another solution. 2 of them, the so-called Singleton design pattern and Fluent API. What is the Singleton? Well, the Singleton, let me find where it was. As you can see here, we go up to 11th version of the page objects. There are many types. Anyway, here my base class for actually let's go to the main page. First, how we use the Singleton. The Singleton class has only one instance and provides access to it. And the basic implementation of the pattern requires a static variable and static property, as you will see in a second. And it ensures that the class cannot be initialized to the keyword new. Right now I haven't done that, but anyways, let's see it in test. As you can see here, instead of creating a private variable, initialize it, etc., basically we call main page instance. This is the private instance of the page. In order to reuse some code and make it more maintainable, instead of implementing this private field, property, etc. In all of the pages, because in production code you have you can have up to 1,000 pages, so it's really a hell if you're going to copy paste it every time. So let's look, but as you can see, it's readable again. It's much more usable. If you know what is the page, you just call the name of the class .instance and call directly the methods. That's it. But as you saw, the code is a little bit more complex. Here, in order to achieve all of this, we use basically generic classes. So here we use generic base abstract class where we paste the type of the page, and basically here with this constraint we tell C# that this type of the page is derived from this base page where we provided this type of the page, and it has a constructor. I know it's ugly, this is not my preferred approach, but anyway, I just show it to you. Some people like it. And how it works, basically we have a private static field called instance, and then we check the first time we call the instance static property. We check whether the variable is null. When it's null, means it's the first time, and then we tell C#, please initialize this page, and we return it. The next time you call the instance property, it directly returns the static. As you know, the static is shared across all of the tests. This means that we will initialize the the page only once. This is not a problem because, as you saw, our implementation for here for the elements, when you call particular element, the library every time goes and finds it, which is good. Let's go back to the presentation. So another approach for improving the API usability is to using the so-called Fluent API. What is the Fluent API? You will see in a minute. But it's also known as method chaining, method cascading, Fluent interface, and it was first described by Eric Evans and Martin Fowler. It should be more concise and more readable, but let's see. To be honest, I'm not sure that I prefer it, but many people and there are many frameworks implement it like this. So, Fluent interface. I think it was in version 10. Here it is. Let's see first how it looks like. As you can see, this is method chaining, meaning that when you call the card page, you call some action, then if you call dot, you will have all other actions that you can perform on this particular page through the IntelliSense. Here you can see all the actions and you can continue to chain them, to cascade them and so on, without the need to type again card page, anything. This is another way how you can write code. There, I don't recall the name, but there was a famous maybe API testing framework in Java that uses this approach and others. How it works? Well, in the main page, basically, when you create a public method, the only difference is that first, instead of your method to be void or return nothing, you return the same type as your page. Here you return the same type, main page, and return this. This in C#, as you know, probably. This is returning the same instance of your page. And this is how, when you return the page, you can chain the methods. Chain the assertions, chain the elements, and so on. This is, again, not my preferred approach, but still many people use it. This is why I wanted to show it to you. What about the extensibility? If you recall, the description of what a software framework and test automation framework is, this is one of the most important parts, the extensibility, or how you can create plugins, how you can add a new code and so on, how you can customize your library or framework. And this is the whole point of, if you don't have this, you don't have a framework, you have a library. I won't have the time to explain all the difference. This is maybe the longest chapter in the book. I won't have the time to explain all the different patterns because most of them are quite complex. However, I will show you example of extensibility where I use strategy design pattern. And the strategy, basically, if I need to explain it in one sentence, it enables an algorithm's behavior to be selected in runtime. And it's really hard to explain it only with a sentence, but I think you will get it when I will show you the example. Let's open the solution. For the extensibility part, actually, we used, by the way, the strategy in many parts of the BELLATRIX framework too. Anyway, here in the demos, you can download the code again, it's free to use. I created a way that you can define your own locators, which, it's not really a thing that you can do in WebDriver. In the previous versions, they used enums. Enums cannot be extended. Right now, if you look, if we decompile the code of Selenium here, let's decompile it. Come on. This is the decompiled code as you can see, this is the part of the WebDriver assembly. And if we check how it's implemented by .id, for example, it's a static method. This means that if you need to add, for example, a locator called id ending with, id starting with, or link text containing, or whatever, you cannot do it because it's static. You need to create, I don't know, maybe another helper function or something. And this is why I showed here in the book how you can use the strategy to implement custom locators. First, I created a class called Native Element Finder Service. It accepts again as composition an interface that comes from the Selenium core library, iSearch Context. iSearch Context interface is basically an interface implemented in the iWebDriver interface and in the iWeb element. As you know, you can find an element in the browser itself, but also you can find an element inside another element. For example, if you find a div, you can call again the find element method and search inside this div. And this is why it's called context, iSearch Context. So here you can basically provide as a parameter iWebDriver or iWeb element, and it will work. And then this class provides a few generic methods that we supply here our buy strategy. Our buy strategy, what it is, you will see in a second, but basically here we call the search context find element. This is the native find element method, and we call our strategy based abstract method defines a convert method that converts from our strategy to the Selenium buy locator. And if we need to see how it works, the buy ID strategy, basically we provide the value in the in the constructor, and then here we call directly the buy.id static method by the value here. So for the buy ID strategy, we use directly the native ID locator in WebDriver. However, for example, our custom new strategy called buy ID containing, we don't use buy ID static method, but actually we created a CSS selector, custom selector for ID containing. And this is how we can implement other, for example, inner text containing. Here we use custom XPath, and so on and so on. Where we use that, there are many other ways. For example, we in the book I implemented such strategies for the wait. For example, we may wait for the element to be clickable. Element is clickable here, you can see such a function, and so on. Again, I'm not going to go to explain it because this is why I wrote a book, because I will need like 1 or 2 hours to explain only this. It's the hard part of the book, but you can read more about it. You can download the code, check it. There are articles again on the blog. But it's a way how you can build a way to extend your framework. An easier way how you can achieve and extend WebDriver in more native way is that part of their NuGet package there is a class called event firing WebDriver. It gives you a point where you can subscribe to, where you can execute your own logic. For example, here they expose these different events where we subscribe these delegates here, and we basically, when we navigate to a certain page, we print this to the console. There are also, I think, events for when the element is found, when the element is clicked, and so on. So you can probably add your own logic here. It's maybe the simplest way how you can achieve that. And a few more things that I wrote a few chapters in the book. Actually, I usually perform a whole conference talk about this theme, about the assessment system. We need a system how you can, for example, when you have one or two automated tests, it usually doesn't matter how you going to write them. You know, you can just write them directly, finding the elements in the test without using facades or page objects. It really no need to use so complex design patterns. But if you plan to have hundreds, thousands of tests, then probably it's much better to use a really good framework, to use design patterns, and follow all of these, you know, different concepts that I mentioned. And then, as you saw, there are at least, this is only about the page objects, there are at least 10 types of them. And there are different designs, whether to use facades or other approach, how you can reuse the workflow, use specflow or not. And you need to measure which design is better. This is why in my previous company and many projects that we use right now to consult companies, we created this assessment system for assessment whether particular architecture is right or not. Again, I usually do, actually you can find a recording on my website on this particular conference talk, so you can watch it, and there are a couple of articles about it, but I will try to summarize it in a few sentences, in a few steps. First, you need to create, and by the way, this is a teamwork. You can do it yourself, however, this will be quite, you know, individual. So first you need to create a research and development branch, different from the one that where your tests are right now. And you need to create a separate projects for each design, whether you use Fluent API or you use you know, different files for the assertions and elements, or you use facades and so on. You need to develop a few tests that are, as I showed you, for example, the best way is to implement the same test with each design. Then you need to present this solution to your team and all of the members that are going to maintain and write new tests, and that will be part of the assessment. And then every participant uses the system and assign ratings. Usually the ratings are from 1 to 5 for the different components here listed. We mentioned a few of them, like the readability. A few of them are actually the high quality attributes. There are a few more, but actually each team member assigns a rating. At the end, we create an average for each criteria, and then we calculate this end result here, and the highest results for the design wins. This is basically it. It's really like a systematic approach for choosing the best architectural design. And lastly, what is the benchmarking? It's like the process of you know, measuring the performance of components, test against one another, against baseline. I'm not going to show you many examples right now, since again you can find it, you can read an article about it. Just give me a second to show it off. Here in the design and architecture section, here there is an article. It's almost completely the whole chapter from the book. You can read it here. Basically, the thing that I explain here is some definitions, of course, to know what benchmarking is. But I will give you a simple example. when we created like half a year ago a complex component part of the BELLATRIX framework for handling and performing actions against complex HTML tables and grids. We had two ways how we can do that, through native WebDriver calls, or to use another library that performs in-memory calls to the HTML and creating all of the locators itself and so on. But we needed to measure whether we need to use complex CSS or complex XPath expressions and so on. And this is why there are many cases where you need to measure the performance of particular component of your library. And this is where benchmarking is perfect. Here you can find many examples for how we use a tool called benchmarking.net. They are similar tools for Java and other object-oriented languages, but the approach and the whole idea is more important than the tool itself. And I think that more and more people should start to do that in order to improve their libraries and frameworks. So, in summary, before proceeding and answering some questions, I told you about some definitions, about the high quality attributes and the solids, and a few patterns. There are many more, and sorry, but I cannot explain them in an hour and a half. This is why I decided to write a book, because it's really complex to do it in short presentations. By the way, you can write some of your questions on the page, and I will try to answer. If you haven't already asked them, beforehand. Some of the resources on Amazon, I already showed you where the book is. On Automate the Planet, there are over 250 free articles. Many people already read them. This is why they like the book, etc. On BELLATRIX solutions, there are many coded examples for how you can get ideas, what you can do in your own framework. You can check all the sites. And now I will try to answer some of your questions. Again, you can ask some of them. So, let me first, I will try to answer some of already asked questions. The first of them was, how many tests do you have in your current project? In my current project, we use our, we work for a big American company, and we're, in my team, under me, there are 5-6 people that write tests, and for 1 year, we created something like 3,000 tests right now. If we run them only on a single thread, they run for many hours, even when they are optimized. But again, they're they're written in a way that we create all of the data ourselves. We check the data in the database. They're not only UI tests, but they're I like to call this type of test system tests, because they even system of system tests, because they test a few systems and the database itself. There is a question also from Iris about the Decorator design pattern. Actually in the book the examples are more up to date, and they are written in a more systematic way with all of the examples from the book. So you can check all of the you can download the source code and check it yourself there, even if you don't have the book. This is fine. Now another question from before is what is the average time of writing one test in your project. It really depends, because as I mentioned, if you need to write a simple UI test and not not a system test, but only clicking on the UI, it's quite easy. You can do it for a few minutes, because it leverages our commercial framework. However, it's really complex sometimes when you need to, for example, when we have a new epic and we need to create all of the data beforehand, then the most time needed before we can write the test is for creating all of the repositories, all of the data itself, all of the connections between the data and the assertions of the data itself. Then like we need least time for clicking on the elements on the page. This is something that the framework gives us. But the actual work is for creating the data and managing it. I think this is the most valuable part. Do programming languages have a role in QA process? I don't understand completely this question. I can tell you because I think recently other people asked me about which languages they need, programming languages they need to learn for this QA role. Like my preferred languages, of course, is C#. But again, another much popular language right now is Java. I believe that C# right now it has much more features. I prefer the Microsoft stack, but anyway, at least 3 times more people are writing on Java, so it's really meaningful to invest in Java or in C#. If you are working on a project with, for example, machine learning or AI, many of these projects uses Python, so Python is also a popular choice. If your project is more front-end oriented with technologies such as Angular, etc., there are other tools like Protractor or WebDriver IO, which is like it uses JavaScript. So it really depends. It's usually much better to use the same languages as your team is using. Can you share your view on trends, tools, programming languages? Which of them are most likely hype? Any advice on what we should aware of? Thanks. Okay. About the trends in test automation, I really think that many people should, instead of trying to create their own framework, test automation framework, there are many open source frameworks written by experts in Java, in Python, in JavaScript, in C#. You should leverage one of them, and if you are so good, you can extend it yourself, add new features, etc. This is how WebDriver and Appium was built. Also, another trend is, of course, many of you, if you go to conferences, know for many years we talk about continuous integration, continued testing. So definitely when you write tests, they should integrate into continuous integration. And this is actually, I don't know the trend, but the best practices, as I mentioned, is to create your own data instead of reusing production. Sometimes this is not possible, of course, it depends. It requires some skills, it depends on the context, but you can always ask developers. In certain cases, 10 years ago when I started to work in the automation field, I just asked my developers for help. You can do the same. Another thing is to leverage Docker. Instead of using virtual machines, there are many popular tools for right now for Appium, for WebDriver that leverage Docker containers like Selenoid. Also for reporting, you can use open source tools like Russian Allure or EPAM report portal. I really like both of them. They really integrate well in Jenkins, in Azure DevOps, and in other popular continuous integration tools. And other trends, of course, are machine learning and so on. Probably some of the tools are, that tell you that you can, with magic button record everything and forget about the tests. I don't believe in them. But in certain cases, machine learning and AI can help you. For example, I think AI and machine learning is quite useful for analyzing test failures. And with accumulating a lot of data, it can be really helpful to help you to prioritize the fixing of the tests. For example, imagine that you have the case where you have 100 failing tests. You need to find out which test to check first, because your time is limited. For example, imagine that you have only 1 hour per day instead of only testing. You need to use your time smartly. And this is a place where AI and machine learning can help you. Another question was when and how often are you use patterns? As I mentioned, if you have only a few tests, it's not optimal to use page objects or anything like that, or facades. They usually pay off the so-called term return of investment when you use them in scale. So I use them only when I work on big projects. Well, in my case, I always work on big projects, so in most cases I use patterns. But if I need to write a simple tool or console application or anything that it's only one class or 100 lines of code, then I don't use patterns. What things we will focus on when you need to rewrite, use the same language but another framework library end-to-end UI tests? Do you have an experience with AI in testing? Maybe this is another question. Okay, when you rewrite, actually for the project that I'm working on right now for this big American company, before another company developed the framework, they built something like 10,000 tests, 10,000 end-to-end tests, but they didn't follow all the best practices. They were a little bit coupled, they depended on each other, not all of the test cases was well written. So the thing that I will focus on will be to first check again the requirements, see whether they are applicable again and still, and try to discuss again with the team whether I will extract from the tests all of the test cases, only abstract with titles, and create a meeting with this particular teams or team and ask them to prioritize them. And we'll see whether this particular, can I add additional test cases or not. And we'll try to follow all the best practices that I know when I rewrite them. It doesn't matter what framework or anything you use. Of course, if you rewrite them, I believe that you should use better framework, of course. Otherwise, why will you rewrite them? So the last questions from the pre-written questions was, do you have an experience with AI in testing? Yes, right now in my company we develop a new set of tools. We work on a new test automation chatbot companion, which actually can help you with you can ask him questions about locators, but the best thing that you can do for you is actually it can apply machine learning algorithm for analyzing the test failures, and it can predict whether there is a real bug in the system or a problem in the test environment, in the test data, in the framework itself, and so on. We usually use the bot chat interface to train it, and yeah, I think it's really helpful because we use another thing like a cloud runner to run our testing through Azure functions with unlimited scale in parallel, and basically after that, when there are test failures, we use this machine learning algorithm to predict what happened and what not. So this is my experience. I'm going to touch refactoring in a few words. This is a long theme. I'm not sure. I will go back in a few seconds. Let me try to answer other questions. Ways to improve the coding standards and rules, if any, or ways to reduce the test execution time of test case. In order to decrease the execution time of test cases, well, actually the things that we looked at the beginning, removing all of the hard-coded pauses, waiting for AJAX requests, all of this will reduce drastically the time for executing the tests. Also reusing the browser. These are all cases that you can use to reduce the time. Another approach is to use parallel test execution or distributed testing. The difference is that parallel execution is usually when you run the test on a single machine in multiple threads, and then you have distributed testing where you execute the test on many machines in parallel. This is parallel distributed testing. And sometimes it's hard, and it really depends whether your application supports it or not. In projects before that I worked on, some of the applications, for example, imagine that have common settings or permissions, and then it's really hard to parallelize the work. It's really hard to parallelize the tests if they depend on each other, so it's important step to make the tests sufficient. It's really hard to distribute and parallelize the tests if they depend on common data, common user. Imagine that you have, for example, a shopping cart, like in our example, and you need to, have a single user, and you need to check whether the purchase was successful. Well, then, if you go to your account and check whether the product was bought or not. If you run the test in parallel, how you can do that if it's a single account? A way how you can do that is if for each test create a new user and then create a purchase. This is a way how we did that in Telerik and in progress for the online shopping cart. As part of the integration testing, is it possible to work with multiple browsers based on the application compatibility for a single test case during the test execution? It really depends on the framework you use. It's something that you need to probably implement yourself. For me, the system tests, it really depends on the needs of the testing. For example, if you test functionally, like our system tests, they don't need to execute in many browsers. For me, it's almost the same whether they execute in Chrome or in Firefox, because we don't check actually the front end. There are different tests that check that. For example, the CSS styles, the layout, and so on. And for that, I believe that you don't need that. I mean, we usually execute the tests in a single browser. However, if you need to check the layout, the different styles in the web browsers, there are many cloud providers like SoSwap's, BrowserStack. Even you can do that in Selenoid, etc. This is an easy way to do it. If you need to do it yourself, you can do it with Selenium Grid, I guess. And about the refactoring, in order to, if I go back to this question in particular, if you follow all of the test maintainability and reusability techniques, if you go back to the solution here, if I go to maintainability solution, if you follow, like if I need to refactor, how it's easy to refactor the test if I use page objects. Well, if I need to, you know, change the element locator here, I will change it only here in the page object. If you use Visual Studio, it's quite easy to refactor tests because there are shortcuts and many other things like removing unused methods, renaming, and so on. But again, if you follow all of the high quality tests, test maintainability principles here with the patterns, it will make the refactoring quite easy. But again, maybe we need a separate webinar for refactoring. It's a really long subject to answer in a single question. So there are many layers of the test these days, like unit integration end-to-end. How not to duplicate tests through all of the layers. The idea of all of these, you know, different tests is another. For example, when you write unit tests, their idea is not to find bugs. Sometimes yes, but when you use test-driven development or you write unit tests, it's more about designing the code, the production code of the application itself. It's not about catching the bugs so much. When you write integration tests, they should be much less. They actually test, for example, store procedures or calling many classes and etc. But their use case and test cases are quite different actually from the end-to-end tests, because I don't think that they can, you know, overlap with the so-called end-to-end or system tests. It's quite different idea. For example, in a project that I worked 2 years ago, they used ETL process for processing data, and there we use integration tests for checking whether ETL is working or not. But the end-to-end tests actually check the UI, whether the data is visualized well in the grids, whether it's filtered, etc. So they don't overlap. And again, if you check the layout, I separate the end-to-end or the so-called system tests from the, you know, from the UI tests, plain UI tests. For me, UI tests are something that you check the responsible design of the page, whether the styles are correct or not, stuff like that. Did you also had mobile testing? How did you achieve distributed testing, not parallel distributing? I did a little bit of mobile. You can achieve that through one way to do it is to, it really depends on the platform actually, whether you test iPhone or Android. For you know, iOS it's really hard because you need to do it on Apple software or Apple hardware. Actually, we hired a few machines in the Apple Cloud that are really expensive, and there you can do it on your own iPhones or devices, or you can start their simulators, but you need to run them on their real hardware. But for Android, actually, we used a little bit of source swaps. We used a little bit of Selenoid guys for Docker. They provide already such simulation for Android, but mostly we used emulators. We actually used our distributed runner. We created a few virtual machines in Azure, and we configured ourselves through command line the emulators, and we used them in Appium Grid, and this is how we run them in emulators basically. But in a past company that I worked for in the past 5 years ago, they were rich enough to buy all of the devices and created their own mobile app and bought all the new phones, etc. And some companies use this approach, and they use these devices for manual testing as well. It's really up to you. I prefer to use usually such devices on demand. That's it. Okay, we are ahead of time, so if you have any questions, you can always contact me through my website, Automate the Planet. Send me an email, there are contact forms, anything, ask me anything. You can download the source code from the GitHub repo. All the examples from the website, already they are on GitHub too. You can download them. So this is it. Thank you for joining us. Thank you for staying for more than half an hour and a half actually. And yeah, thank you.